Imagine stepping out of the front door of your childhood home.
Okay, I'm picturing it.
Right. So you walk down your street, you reach the end of the block, and you just turn around.
Yeah.
And in that fraction of a second, your perspective violently shifts.
Yeah.
Like you realize that your entire universe, the house, the family, all the internal logic of the walls that felt like the boundaries of reality itself, it's all just one infinitesimally small structure. And it's sitting in this vast, overwhelming neighborhood that you've just, never properly mapped.
Right. The physical space hasn't actually changed at all, but your cognitive map has been entirely rewritten. You're suddenly forced to reconcile your localized experience with this broader, completely indifferent geography.
Exactly. And welcome to this deep dive. Because today, our mission is to explore a single world-changing artifact that forced that exact cognitive rewrite on the entire human species.
It really did.
We're looking at a moment that materialized on December 7, 1972. It was a 1/1250th of a second shutter click on a Hasselblad camera that yielded frame AS17-148-22727.
Or, as it's better known to the world, the blue marble photograph.
The blue marble, yeah. Captured by the crew of Apollo 17. And it stands as the most reproduced image in human history.
Which is wild to think about. And tracing the journey of this image, it requires us to dismantle a lot of preconceived notions, I think.
Oh, absolutely.
Because we're going to dissect the geopolitical crucible of the Cold War that, forged the technology in the first place, plus the exact orbital mechanics and the optical physics that made the shot possible.
Right.
And then the profound neurological shift that astronauts experience, which is known as the overview effect.
Yeah, and from there, we have to evaluate the subsequent environmental legislation that it catalyzed, the birth of Earth system science, and finally, the philosophical critiques that argue this pristine image actually alienates us from the harsh realities on the ground.
There's a lot to unpack.
There is. So the natural starting point is the geopolitical tension that birthed the hardware. The 1960s and early 70s were defined by this persistent background hum of existential dread.
Oh, yeah, the Cold War.
Right. But looking at the sources, I'm struck by a mechanical paradox here.
How so?
Well, the Saturn V rocket, right? This majestic vessel of exploration that gave us the ultimate symbol of global unity.
Yeah.
It's as fundamentally a repurposed weapon of mass destruction.
Yeah, that is the dark irony of the space race. We are looking at the direct evolutionary offspring of the V-2 ballistic missiles.
The V-2 rockets.
Yeah.
Like from World War II.
Exactly. Because the mathematics of delivering a nuclear warhead across the globe, they are virtually indistinguishable from the mathematics of putting a capsule into low Earth orbit.
Wow. I mean, it makes sense, but hearing it said out loud is just wow.
Right. The V-2 rockets, which were developed in Germany for, city-leveling destruction, they established the foundational principles. Things like staging, gyroscopic guidance, liquid propulsion.
So the DNA of the Apollo program is literally a weapon.
Yes. When Wernher von Braun and his engineering team were brought to the United States under Operation Paperclip, their primary mandate wasn't philosophical enlightenment.
I would assume not.
No, it was the development of intercontinental ballistic missiles, the ICBMs.
Right.
The Redstone and Jupiter rockets that carried the first Americans to space, they were originally military launch vehicles. I mean, even the Hasselblad cameras the astronauts wielded had their origins in aerial reconnaissance and military surveillance.
That's fascinating. And geographer Dennis Cosgrove, his analysis points out that the blue marble's visual of planetary unity is a direct byproduct of Cold War territorial aggression.
Yeah, it's a huge paradox.
It's like two superpowers were locked in a zero-sum game for technological supremacy, right?
Yeah.
They're attempting to weaponize the ultimate high ground. And in the process, they inadvertently manufactured a mirror for humanity.
That's a great way to put it. The irony is deeply embedded in the historical record. The infrastructure required to leave the planet was entirely funded by the fear of losing it to an ideological enemy.
Right. Now, the blue marble wasn't actually our first glimpse of the Earth from a distance.
Yeah.
And the progression of the imagery is important to track here.
Yeah, it didn't just happen overnight.
No. So in 1966, the Lunar Orbiter 1 transmitted a black and white image of Earth from the moon. And then in 1967, the ATS-3 satellite provided a color image.
But those earlier images lacked the visceral impact.
Exactly. The satellite data was heavily clouded, it was grainy, and the lunar orbiter shot was black and white, heavily shadowed, and framed by this stark, dead surface of the moon.
Right, they were technical achievements, but not really emotional ones.
Yeah, no one was putting them on a poster.
Exactly. But then came 1968. William Anders aboard Apollo 8 captured the famous Earthrise photo?
That one is iconic.
It is. It's the Earth rising over the desolate lunar horizon in partial shadow. And historian Robert Poole characterizes that specific frame as a tipping point.
A tipping point for what?
A moment where the prevailing narrative of the space age flipped. The public conversation shifted from what this technology meant for the conquest of space to what it meant for our understanding of Earth.
Oh, I love that. And that shift was actively being engineered on the ground, too. The sources highlight this fascinating campaign by Stuart Brand.
Oh, the Whole Earth Catalog guy?
Yes, the visionary behind the Whole Earth catalog. In 1966, Brand reportedly had a profound experience on an LSD trip.
Naturally.
Yeah, right. He's on a San Francisco rooftop, and he perceived the curvature of the Earth. And he developed this absolute obsession with the idea that if the public could just see a photograph of the entire, fully illuminated planet, it would fundamentally alter human consciousness.
He was pretty far ahead of his time on that.
He really was. And he didn't just write about it, he launched a guerrilla campaign. He printed and sold these 25-cent buttons that simply asked, why haven't we seen a photograph of the whole Earth yet?
Just a simple question on a button.
Yeah. And he distributed them on college campuses, sent them to politicians. He even managed to get them into the hands of NASA administrators.
That's brilliant, really, because Brand was tapping into a latent cultural hunger.
What do you mean?
Well, the mid-1960s saw the rapid expansion of global communication networks. You had the escalation of the Vietnam War playing out on television every night.
Oh, right. The living room war.
Exactly. And the early rumblings of environmental degradation. People intuitively grasped that local actions had global consequences, but they lacked a unifying visual icon to anchor that abstract concept.
So they needed a picture to tie it all together.
Yeah, Brand hypothesized that a macro perspective would force a micro-behavioral shift.
That's profound. I look at the timeline of the Apollo program, and I have to wonder about the trajectory of the space race itself. Because it begins as this aggressive, outward thrust of manifest destiny. Right, planting flags, collecting rocks, beating the Soviets.
Very conquest-driven.
But by the time we reach Apollo 17 in 1972, which is the final human lunar mission, the cultural and scientific yield seems to have completely inverted.
Yeah, it flipped inward.
The greatest return on investment wasn't what we found out there, but the perspective we brought back. Apollo 17 was humanity's last foray into deep space. No human has been far enough away from the Earth to capture a fully illuminated shot of the planet since.
Which is a staggering thought. The phasing out of the Apollo program really frames the Blue Marble with this profound historical melancholy.
Yeah, a closing chapter.
Exactly. It serves as the closing bracket to an era of explosive outward expansion. And the transition from outward conquest to inward reflection is physically embodied in the orbital mechanics that allowed the photograph to be taken in the first place.
Oh, the mechanics. This is where the story transitions from geopolitics to pure physics.
Yes.
Okay, so December 7th, 1972. The photograph is snapped exactly 5 hours and 6 minutes after the Apollo 17 launch. The command module, America, is coasting outward on its translunar injection trajectory.
Roughly 29,400 kilometers away from the surface.
That's about 18,300 miles.
Right. Yeah, exactly. And the serendipity of that exact positioning cannot be overstated.
Because it wasn't planned, right?
No, Apollo 17 was unique. It was the first and only nighttime launch of the Apollo program. And it was delayed by an automatic sequencer failure.
So they were off schedule.
Right. And because of the timing of that translunar injection burn, the spacecraft's trajectory placed it directly on the Sun-Earth line.
Okay, so the spacecraft is positioned perfectly between the Earth and the Sun. From the astronaut's perspective, the Sun is directly behind them.
Yes. In photographic terms, it's the ultimate application of flat, direct front lighting.
Which means no shadows. A fully illuminated sphere.
Exactly. And in celestial mechanics, achieving a fully illuminated shadowless sphere from a human-occupied spacecraft is highly improbable. You are managing a very chaotic environment of operational constraints.
What kind of constraints?
Well, for one, the spacecraft is executing the passive thermal control maneuver, colloquially known as the barbecue roll.
The barbecue roll. That's amazing. To prevent the side of the spacecraft facing the Sun from superheating, right? While the side facing deep space freezes.
You got it. So the ship is slowly rotating on its longitudinal axis, spinning like a rotisserie chicken.
Okay, so the windows are constantly moving.
Exactly one rotation every 20 minutes. So the windows are sweeping across the blackness of space, the blinding sun, and then the Earth.
Wow.
Furthermore, the crew is occupied with navigation, systems checks, and communicating with Houston. The window of opportunity to frame a fully lit Earth without the Terminator line casting half the planet in darkness was incredibly fleeting.
And let's examine the optical hardware that captured this fleeting window. Because they weren't using iPhones. They used a Hasselblad 500EL data camera.
Yeah, the Hasselblad.
But this isn't off-the-shelf consumer gear.
Mm.
NASA required severe modifications, like the traditional viewfinder was removed.
Right, because an astronaut wearing a pressurized helmet visor cannot press their eye against a camera body.
That makes total sense.
Yeah.
The buttons were oversized for the bulky EVA gloves. The lens was an 80mm Zeiss sonar, renowned for its incredible resolving power and lack of optical distortion.
The lens is important, but the choice of film stock is equally critical to the physics of the image. NASA utilized 70mm Kodak Ektachrome color reversal film.
Why that specific film?
Well, space is a deeply hostile environment for photochemistry. You are dealing with a vacuum.
And what does a vacuum do to film?
It can cause the emulsion layers of standard film to outgas or just literally crack. Plus, you have extreme thermal fluctuations and high levels of ambient cosmic radiation that can completely fog the film.
So Ektachrome was just tougher.
Yeah, Ektachrome was selected for its robust dimensional stability and its remarkable color fidelity. Specifically, its ability to render the deep, saturated blues and stark whites of the Earth against the absolute black of space without blowing out the highlights.
So the aperture is set to f2.8, the shutter speed at 1250th of a second. A mechanical click in the vacuum of the command module, and they capture a view that fundamentally disrupts centuries of cartographic tradition.
It really did, because when you look at the blue marble, it centers squarely on Africa.
Yes, the Arabian Peninsula, the swirling white mass of Cyclone 16B over the Indian Ocean, the deep rust-colored expanse of the Sahara, and Madagascar floating off the coast.
Right. And Western mapmaking, which is heavily influenced by the Mercator projection, traditionally places Europe or North America at the dominant center, visually inflating their land masses.
Because the Mercator projection was a navigational tool that basically mutated into a political one.
Exactly. By distorting the higher latitudes, it subconsciously reinforced Northern Hemisphere hegemony.
But the blue marble didn't care about that. It was dictated entirely by the impartial physics of orbital trajectories. It stripped away the graticule.
The graticule.
Yeah, the artificial grid of longitudes and latitudes we project onto the globe. Historian Robert Poole correctly identifies this specific framing as a photographic manifesto for global justice.
I love that quote. It presented the Earth as an integrated biological entity, totally indifferent to the arbitrary borders drawn by colonial powers.
But the discussion of spatial orientation brings up a really jarring psychological reality about the photograph, and I find this part so wild. The image, universally recognized today, Africa upright, Antarctica at the bottom, is a manipulation.
Yeah, a lot of people don't realize that.
When the shutter was pressed, the camera was oriented such that Antarctica was at the top of the frame.
Right. Because human spatial orientation relies heavily on the vestibular system in the inner ear, which detects gravity to establish a constant sense of down.
So in space, what happens to that?
Well, in the microgravity environment of translunar coast, the vestibular system is effectively silenced. The brain is forced to rely entirely on visual cues to determine orientation. To the astronauts, up was simply wherever their heads were pointing relative to the spacecraft's interior.
Right, the local geometry of the capsule dictates their reality. So when they look out the window, the Earth is just hanging in the void with the South Pole pointed toward the roof of the spacecraft.
Exactly. But when the film returns to Houston and NASA processes the Ektachrome, they make a conscious editorial decision. They rotate the image 180 degrees before releasing it to the press.
Just literally turn it upside down.
Yeah. The cognitive load of processing an upside-down Earth was deemed too distracting for the public. We are so biologically and culturally hardwired to favor a north-up orientation that presenting the image exactly as it was captured would have caused widespread spatial disorientation.
It perfectly demonstrates our compulsion to impose familiar frameworks onto the infinite. Like, we are handed a true representation of the cosmos where direction is completely meaningless, and our immediate reaction is to manually rotate the planet so it matches the globe sitting on our elementary school teacher's desk.
It's a subtle but profound act of psychological domestication.
Psychological domestication, yeah.
We made the vastness of space conform to our terrestrial comfort zone. which, leads to the enduring ambiguity surrounding the authorship of the artifact itself.
Oh, right, because to this day, the specific individual who actually pressed the shutter remains a subject of historical debate.
It does. NASA's official policy was to credit the entire crew. Commander Eugene Cernan, Command Module Pilot Ronald Evans, and Lunar Module Pilot Harrison Jack Schmitt.
Which reinforced the narrative of mission-oriented teamwork.
Right, very NASA. But analyzing the mission transcripts and the physical layout of the command module provides some pretty compelling circumstantial evidence.
Pointing to who?
Harrison Schmitt. He was the only professionally trained scientist astronaut to walk on the moon. He was a geologist.
Okay, so he's looking at rocks.
Right, and during that specific phase of the flight, Schmitt was positioned at the right-hand window. The audio transcripts capture him actively requesting the camera to photograph the weather patterns, specifically noting the cyclone over the Indian Ocean.
Oh, so he's the one talking about the weather.
Yes. His geological background made him acutely aware of the atmospheric and lithospheric structures visible below.
And what about the others? Cernan has vaguely suggested he might have taken it, right?
He has. And Evans was heavily occupied with the spacecraft controls. So without an indisputable time-stamped log correlating the film magazine to the exact holder of the camera, we have to rely on deductive reasoning. Schmidt's scientific intent strongly aligns with the composition of the photograph.
Regardless of whether it was Schmitt or Cernan, the human intent behind the lens acts as the bridge between the physical hardware and the psychological phenomena we need to unpack next.
The overview effect.
Right. Because the act of looking through that viewfinder triggers a documented cognitive cascade. Space philosopher Frank White formalized this cascade in 1987.
Frank White coined the term.
He did. He interviewed dozens of astronauts and cosmonauts, isolating a shared psychological shift. To understand the overview effect, we really have to look past the colloquial description of awe and examine the neurological mechanics.
So what's actually happening in the brain?
Viewing the Earth from a distance triggers a state of self-transcendence. The human brain's default mode network, the interconnected regions responsible for self-referential thought, ego, and the boundaries between self and other, experiences a downregulation.
That makes sense. When the brain is confronted with a visual stimulus that is so vast it defies current cognitive schemas, it undergoes a process called accommodation.
Accommodation.
Yeah. The mind basically attempts to stretch its existing frameworks to process the new data. And during this severe accommodation, the borders of the ego soften.
So they literally feel more connected to everything.
Exactly. Astronauts consistently report an overwhelming influx of interconnectedness. The abstract knowledge that national borders are arbitrary geopolitical fictions is suddenly transformed into a glaring, undeniable physical reality.
It's the transition from intellectual understanding to visceral sensation. Like, I can look at a map and conceptually acknowledge that the line separating the United States from Mexico is just ink on paper.
Right.
But an astronaut in orbit looks down and sees a continuous, undivided geological expanse. The atmosphere doesn't recognize sovereignty.
It really doesn't. And Frank White emphasizes a crucial variable in the intensity of the overview effect.
Yeah.
The distance of the observer.
Distance matters.
Very much so. The psychological impact scales with altitude, specifically the difference between low Earth orbit, or LEO, and translunar space.
Let's quantify that visual difference for a second. On the International Space Station, astronauts are orbiting in LEO at an altitude of roughly 400 kilometers, traveling at 28,000 kilometers per hour.
So the Earth fills their entire visual field. Eugene Cernan likened LEO to riding a roller coaster. The surface is rushing past. You are acutely aware of the velocity and the massive physical scale of the planet directly beneath you.
It's like having your nose pressed against a mural.
Yes. In LEO, the Earth acts as a ceiling or a floor. It dominates the visual arc. But from translunar space, approximately 380,000 kilometers away, the visual arc seconds the Earth occupies shrink drastically.
So it's not a landscape anymore.
No, the Earth ceases to be a landscape and becomes a discrete, finite object suspended in a three-dimensional void.
And Apollo 14's Edgar Mitchell described this specific translunar vantage point as triggering a universal insight. The observer's psychological anchor detaches from the Earth and temporarily binds to the cosmos.
The planet transforms from a dominant environment into a vulnerable artifact.
Vulnerable artifact. I really feel that. And the emotional reactions recorded by the Apollo crews run the gamut of the human condition. Like, Michael Collins on Apollo 11 looked out and described the Earth as shiny, beautiful, home, and fragile.
Alan Shepard, the hardened test pilot and first American in space, he stood on the lunar surface, looked back, and wept.
Literally cried. And we saw a stark modern articulation of this when William Shatner flew on a suborbital trajectory.
Oh, that was a powerful moment.
It was, because the cultural expectation was that Captain Kirk going to space would yield profound joy.
Right, a triumphant TV moment.
Instead, Shatner experienced an overwhelming sense of grief. He looked outward into the absolute blackness of the cosmos and described it as death, a cold, unblinking void.
And then he looked down at the thin blue line of the atmosphere and described it as mother and earth and comfort.
Shatner's reaction is just a pristine data point for the overview effect. It highlights the terror of the vacuum, the realization that this impossibly thin layer of gas, the biosphere, is the only mechanism preventing the annihilation of every biological organism, every piece of art, every memory that has ever existed.
It forces a complete recalibration of threat assessment.
Definitely.
And the profound implication of the blue marble photograph is that it packaged that localized, highly exclusive cognitive shift and broadcast it to the billions of humans anchored to the surface.
It was a mass psychological contagion.
Exactly. And the timing of its release in December 1972 intercepted the exact peak of a rapidly accelerating cultural shift.
Yeah, the late 60s and early 70s were a period of intense ecological awakening, mostly driven by localized disasters, like Rachel Carson's 1962 publication of Silent Spring mapped the devastating systemic impacts of synthetic pesticides.
And the 1969 Santa Barbara oil spill coated the California coastline in crude, providing visceral television footage of dying marine life.
Right, or the Cuyahoga River in Ohio. It was so choked with industrial pollution that it repeatedly caught fire.
A river catching fire is hard to ignore.
It really is. And these events generated immense public outrage, which culminated in the first Earth Day in 1970.
However, the movement was heavily fragmented at that point. Activists were fighting localized battles against specific corporate polluters or regional policies.
They lacked a macro-level icon.
Exactly. They didn't have proof of the interconnectedness of their various causes. The blue marble dropped into this volatile cultural atmosphere and instantly unified the narrative.
So the smog over Los Angeles and the toxic sludge in the Cuyahoga River were no longer isolated incidents of municipal failure. They were actively degrading the life support systems of a singular, delicate sphere.
This is the moment the concept of spaceship Earth transcends academic theory and becomes a mainstream paradigm.
I want to talk about spaceship Earth, because the architect and systems theorist Buckminster Fuller had been evangelizing that concept for years, right?
Yes, Fuller was way ahead of the curve. He proposed that the Earth is a mechanical vehicle, a spherical ship traveling at 100,000 kilometers per hour through the vacuum of the solar system.
And what's the core of that metaphor?
Thermodynamics. A spaceship is a closed system. It possesses finite resources, a strictly bounded capacity for waste absorption, and a delicate, interdependent life support matrix. Furthermore, Fuller insisted that humanity must stop acting as passive passengers and assume the responsibilities of the crew.
Okay, I have to push back a little on Fuller's metaphor when applied to our current trajectory. Because if the Earth is a spaceship, it was delivered without an operating manual. As a species, we resemble a mutinous crew that has entirely lost the plot.
That's a grim picture.
Well, think about it. We are actively dismantling the ship's vital life support infrastructure. We're tearing wires out of the atmospheric scrubbers just to build slightly more luxurious seating in the first-class cabin.
Wow. Your critique highlights the exact friction the blue marble exposed. The photograph made the absurdity of infinite resource extraction on a finite planet visually undeniable.
And people responded to it quickly.
They did. The immediate global adoption of the image was staggering. It became the de facto flag of the environmental movement. Greenpeace utilized it. Stuart Brand placed it on the cover of the Whole Earth catalog.
And the Club of Rome heavily leveraged the imagery for their seminal 1972 report, The Limits to Growth, which used computer modeling to warn of systemic ecological and economic collapse if consumption trends continued.
Right, and Stuart Brand made a fascinating observation about the semiotics of the era. He noted that the blue marble effectively replaced the Cold War mushroom cloud as the dominant icon of global consciousness.
We transitioned from an image symbolizing the terrifying, instantaneous destruction of humanity to an image symbolizing delicate, unified preservation.
And that symbolic shift correlated with unprecedented legislative action.
Real laws being passed.
Yes. In the United States, the early 1970s saw the establishment of the Environmental Protection Agency, the passage of the Clean Air Act, and the Clean Water Act.
So the image operationalized environmentalism. It allowed politicians and the voting public to emotionally grasp the abstraction of an interconnected biosphere.
But the legacy of the blue marble extends past cultural symbolism and into the rigid domain of the hard sciences.
Oh, this part is fascinating.
The visual data literally restructured how scientists approached the planet.
Which is wild, because a theoretical physicist or a meteorologist doesn't rewrite their equations simply because they saw a beautiful piece of ectochrome film. How exactly does a photograph alter the methodology of empirical science?
By exposing the fatal flaw in academic siloing. Prior to the space age, the earth sciences were highly compartmentalized.
Everyone in their own lane.
Exactly. Oceanographers studied ocean currents. Meteorologists modeled atmospheric thermodynamics. Geologists analyzed tectonic shifts. They operated completely independently, assuming the variables of the other disciplines were just static background noise.
They were studying the organs without recognizing the patient.
Precisely. The blue marble visually demonstrated that the planet operates as a coupled system. You can literally see the atmospheric systems interacting with the oceanic heat sinks, which in turn dictate the weathering of the lithosphere.
So you can't ignore the other disciplines anymore.
No, you can't. And this catalyzed the formalization of Earth system science. Following the dissemination of Apollo imagery, funding models shifted, and memberships in organizations like the American Geophysical Union surged.
Scientists began developing coupled global climate models, integrating the Navier-Stokes equations for fluid dynamics across both the atmosphere and the oceans simultaneously.
Right. And this holistic approach paved the way for James Lovelock's Gaia hypothesis in the 1970s.
Remind me what the Gaia hypothesis is.
Lovelock proposed that the Earth's living organisms interact with their inorganic surroundings to form a synergistic, self-regulating, complex system that helps maintain the conditions for life on the planet.
Wow. And the blue marble was essentially the visual abstract for the Gaia hypothesis.
It provided the macro perspective required to conceive of the biosphere as an active, regulating entity rather than just a passive backdrop.
But the scientific utility of the 1972 photograph has morphed over the past 5 decades. It has transitioned from a revelation into a baseline.
A very sobering baseline.
Yeah, it is a frozen data point of the Earth's albedo and physical state from half a century ago. When climatologists overlay modern satellite data onto the exact framing of the 1972 blue marble, the physical degradation of the planet is stark.
You can see the changes.
Yes, the extent of the Antarctic ice sheet, which is brilliantly white at the bottom of the original frame, has measurably receded. We can track the desertification expanding the rust colors of the Sahara.
And the most critical changes are invisible in the visible light spectrum, but they define the reality of the system.
Like what?
Well, when Jack Schmidt or Eugene Cernan pressed the shutter in December 1972, the atmospheric concentration of carbon dioxide was approximately 325 parts per million.
And today?
Today, that concentration exceeds 420 parts per million. The blue marble is no longer just a beautiful photograph. It is a damning indictment of the Anthropocene.
And the scientific reality of the Earth as a coupled system fundamentally delegitimizes regional approaches to atmospheric policy. A metric ton of methane emitted in an unregulated industrial zone in one hemisphere instantly becomes a structural problem for the agricultural systems in the opposite hemisphere.
Right, because the atmosphere doesn't care about borders.
The system is unified, which demands the stewardship be unified.
That is the logical conclusion of Earth systems science. However, the assumption that the blue marble is a universally unifying force is heavily contested in academic circles.
Let's pivot to that. We need to look at the criticism.
We must rigorously examine the blind spots of the overview effect, because historians and philosophers argue that this pristine, borderless image actually obscures the brutal realities of human existence.
Let's delve into Jordan Bim's critique.
The science historian.
Yes, Bim challenges the fundamental premise of the overview effect. He argues that the profound sense of cosmic unity reported by the astronauts isn't an inherent natural psychological response, but a highly engineered cultural construct.
Bim's analysis focuses on the demographics and the context of the observers.
Who were they?
Well, the individuals experiencing the overview effect during the Apollo era were highly trained military test pilots and scientists steeped in the ideologies of the Cold War and the Western narrative of manifest destiny.
So they weren't exactly a random sample of humanity.
Not at all. They were looking down from the apex of a multi-billion-dollar technological pyramid. BIM warns of what he calls the overlord effect.
The overlord effect, what is that?
It's a hubristic, detached sense of enlightenment derived from occupying a position of ultimate panoptic mastery over the planet.
The perspective is inherently privileged. I mean, it is easy to feel a serene, transcendent peace with humanity when you are hermetically sealed in a titanium capsule 30,000 kilometers away from the friction of actual life. The blue marble shows a swirling mix of clouds and oceans. It does not show systemic poverty. It does not show the battlefields of Vietnam, which were actively raging as the photo was taken. It doesn't show apartheid or resource wars.
This specific erasure of human suffering aligns perfectly with the Heideggerian concept of world alienation.
From the philosopher Martin Heidegger.
Yes. Heidegger warned against the technological framing of the world, what he called Gestell or N-framing. When we view the Earth purely from a technological orbital vantage point, the planet is reduced to a standing reserve, a manipulable object, or an image to be processed.
So by turning the Earth into a smooth, borderless marble, we alienate ourselves from the grounded, messy, localized reality of existing on the Earth.
The macro perspective actively works to erase the micro-realities of the billions of people struggling for survival.
It creates a dangerous gap between awareness and action, and the image is easily co-opted. Like a multinational petroleum corporation can slap the blue marble on their annual sustainability report to signal environmental awareness.
While effectively greenwashing their continuous extraction of the planet's resources.
Exactly. The photograph becomes an aesthetic logo rather than a call to radical systemic change.
It's a valid critique. And we also have to acknowledge that the psychological responses to high altitude are not universally positive. The overview effect is the dominant narrative, but aerospace medicine has documented much darker cognitive shifts.
Really? Like what?
While in the 1950s, researchers Brant Clark and Ashton Grabiel studied the break-off phenomenon in high-altitude jet pilots.
High-altitude jet pilots. So not quite space, but close.
Right, stratosphere level.
Right.
These pilots flying solo frequently reported profound feelings of physical isolation, severe detachment from the Earth, and intense anxiety.
So not a feeling of oneness.
No, the exact opposite. The break-off phenomenon demonstrates that separating the human body from its terrestrial anchor can trigger existential terror just as easily as it triggers transcendent awe.
And anthropologist Dina Weibel expands on this with her research into the ultraview effect.
The ultraview effect, yeah.
This occurs when astronauts look away from the illuminated Earth and out into the deep field of space. The overview effect provides a sense of connection to the home planet. But the ultraview effect, generated by staring into the unblinking infinite expanse of the stars, triggers a crushing sense of insignificance.
The observer is confronted with the incomprehensible scale of the universe, leading to a profound self-diminution.
The contrast is jarring. Looking toward the Earth reinforces a sense of biological community. Looking away reinforces our absolute vulnerability in a hostile void.
These psychological phenomena highlight how context-dependent our perception of reality truly is. And our context for viewing the Earth has shifted dramatically since 1972.
Yeah, let's talk about the modern day, because the 1972 blue marble is not the only image we have. NASA and other space agencies have released a continuous stream of modern Earth imagery.
We have the 2001 blue marble.
Right, and the incredibly high-resolution 2012 image from the Suomi NPP satellite. And the daily feeds from the DSKVR satellite's ITIC camera, stationed at Lagrange Point 1.
We also have the black marble visualizations.
Oh, I love those. Tracing the sprawling webs of human city lights across the nocturnal hemisphere.
They are beautiful, and the resolution and data density of these modern images are orders of magnitude greater than Ektachrome film. However, there's a fundamental ontological difference in how these images are constructed.
They aren't photographs, are they?
No. The overwhelming majority of modern photographs of the Earth, like the 2001 and 2012 blue marbles, are not photographs in the traditional sense. They are data visualizations.
They're stitched composites.
Exactly. Satellites in low Earth orbit, utilizing instruments like MODIS or VIARs, scan the Earth in swaths over the course of days or weeks. Terabytes of raw data are beamed back to servers.
And then computers take over.
Right. Computers filter out cloud cover, mathematically balance the atmospheric scattering, correct the lighting, and map the synthesized data onto a digital 3D sphere.
So the output is a manufactured representation of the Earth optimized for scientific utility, not a single temporal capture of light.
The DSKVR satellite does take full disk images, but it operates autonomously. A machine executes a programmed subroutine.
This is where the 1972 blue marble retains its irreplaceable gravity. It operates as the ultimate Turing test for photography.
How so?
Well, I view the modern composites the way I view an AI-generated portrait. An algorithm can synthesize millions of data points to generate a technically flawless, hyper-realistic face. It is perfect, but it is empty.
It lacks a human element.
Right. The 1972 photograph is like finding a slightly grainy physical Polaroid of your mother hidden in a drawer. The analog image possesses an undeniable soul because of the intentionality behind the lens.
Intentionality is the defining metric here. Because a satellite algorithm does not experience the break-off phenomenon, a machine does not feel the awe of the overview effect.
Exactly.
Jack Schmidt, floating in the command module, felt the crushing emotional weight of the planet he was observing. He made the conscious human decision to frame the shot and actuate the shutter. The 1972 Blue Marble is a mechanical recording of human empathy.
Synthesizing the immense scope of this deep dive into frame AS17148-22727, it requires holding multiple contradictory truths simultaneously.
It really does.
The blue marble is the technological offspring of Cold War ballistic missile research that miraculously birthed the ultimate icon of global peace. It forced the realization of Spaceship Earth, acting as the catalyst for the modern environmental movement and Earth system science.
Yet, it serves as an undeniably tragic baseline for the acceleration of climate change.
It democratized the transcendent awe of the overview effect, even while standing accused of erasing the localized suffering of billions through the Heideggerian overlord perspective.
It operates as a mirror, reflecting both our greatest capacity for interconnected understanding and our most dangerous blind spots regarding our exploitation of the planet.
To you, the listener, navigating the friction of daily life on the surface, the next time you open a mapping application on your phone to navigate a city street, take a moment to look at the artificial borders overlaying the terrain.
They're just lines on a screen.
The lines separating nations, states, and neighborhoods are fictions we collectively agree to enforce. But the physics of the thin blue atmosphere regulating your temperature, the oceanic currents driving the weather outside your window, that is the undeniable shared reality. You are not a passenger on this rock. You are an active member of the crew of Spaceship Earth.
And that leads us to a necessary, perhaps unsettling extrapolation of the overview effect. As humanity pushes into a new era of commercial spaceflight, and as aerospace agencies aggressively target crewed missions to Mars, we are approaching a novel psychological threshold.
We are.
When a human crew travels millions of kilometers outward, the Earth will shrink from a blue marble into a single, indistinguishable pale blue dot.
The ultimate distance.
If the 1972 photograph catalyzed a sense of planetary unity by showing us the entirety of our home, what cognitive shifts or existential terrors will emerge when human beings look out the window and can no longer resolve the Earth at all?
A profound psychological frontier. To everyone supporting GL Deep Dives, thank you for being part of this journey. If you're enjoying the show, make sure to follow and subscribe because this is only the beginning.